In this video, we will see how to solve systems of equations with two variables using the determinants method. This method is also called Cramer's rule. Before we start, first we need to see what are determinants and how we solve them. A determinant is an array of numbers enclosed by two vertical bars, like this example. Here in yellow on the screen, we have a determinant of 2 by 2. We can have larger determinants of 3 by 3, 4 by 4, or larger. But since we're studying systems of equations with two variables, we will only be working with determinants of 2 by 2. Now, every determinant represents a value, a number, and its value is equal to the product of the elements of the main diagonal minus the products of the secondary diagonal. The main diagonal in this example would be 1 times 2, and the second diagonal would be 8 times 5. So in order to find the value of this determinant, first we had to multiply 1 times 2, which is from the upper left to the bottom right, and then subtract the result of multiplying 8 times 5. 1 times 2 gives us 2, 8 times 5 gives us 40, and 2 minus 40 gives us minus 38. In order to solve a system of equations with two variables by determinants, we will use these three formulas that you have on the screen. If you see, all of them have letters A, B, and C, and all of them have a subindex. The number that you have in the subindex, which is 1 or 2, means that you have two equations. All the letters that have a subindex of 1 are values that come from our first equation, and the others that have the subindex of 2 come from the second equation. So in order to use the formulas, we must have our system of equations with our equations ordered, with the value of x first, then the value of y, then our equal sign, and then our constant number. The coefficients of x will be represented with the letter A. The coefficients of y will be represented with the letter B, and our constant numbers with the letter C. So when you have A1, it means that you have the coefficient of x of your first equation. And if, for example, you have C2, means the constant number of your second equation. The first formula that says D equals, this is called the determinant of the system. That determinant, or that value, is needed to find the value of x and y of your system. If you see the other two equations that have x equal and y equal, both are divided by the determinant of the system. So the first value that we need to calculate is the determinant of the system. So now let's see an example with actual values. Here we have our first system of equations of 2 by 2. We have two equations with two variables, x and y. So first we must make sure that we have it in order. First the value of x, then our value of y, then our equal sign, and then our constant number. Since this one is already ordered, now we just have to identify which one is each variable. So first let's see our coefficients of x. We said they're A. So A1, the coefficient of x of our first equation, this one will be our first equation, this one will be our second equation. So A1 is 2, the coefficient of x. Now A of the second equation, the coefficient of x of the second equation is 3. Now let's go with the coefficients of y, which are represented by the letter B on the formula. B of the first equation is 3. B of the second equation is -2. It is very important not to forget the sign of each coefficient. Remember that its sign is the symbol that you have on the left. Okay, now let's go with our constant numbers, which are C. C of the first equation would be -1, and C of our second equation is -8. Okay, now that we know which ones are A, B, and C, we are going to first calculate the determinant of the system, this one. So the formula says that D equals, now we open our first bar, A1, we have it here, 2. And below that, A2, which is 3. Now B1, which is 3. And below that, B2, -2. Now when we saw how we solved determinants, we said first we multiply the main diagonal. The main diagonal is from upper left to bottom right, like that. So in this case, it's 2 times -2, and then we will subtract the product of the secondary diagonal, which is like that. In this case, 3 times 3. Okay, now we solve the operation. 2 times -2, -4, minus 3 times 3, 9. Now we just subtract -4 minus 9, that is -13. Okay, so this value, -13, this is the determinant of the system. We will need that value to find the value of x and to find the value of y. Now let's first find the value of x. X equals, okay, first we are going to write the determinant. It says C1. So C1 is -1. Now C2. C2 is -8. -8. Now B1, 3. B2, -2. Okay, that is a determinant we need to solve for x, but the formula says to divide over the determinant of the system, which we already calculated here, is -13. Okay, now with the same steps, we are going to solve the determinant of the denominator. I'm sorry, the numerator. Main diagonal, -1 times -2. So -1 times -2. We will subtract the secondary diagonal, -8 times 3 equals. Now, -1 times -2, 2. Minus -8 times 3, that's -24. Okay. Oh, and let's not forget that this is over -13. Over -13. And negative becomes positive, so 2 plus 24 over -13. 2 plus 24, 26 over -13. And 26 over -13 is -2. Okay, so now we have our value of x. X equals -2. Okay, now we need to find the value of y as well. Let's solve now for the second formula. Well, actually, third formula. Y equals, we write the bar. Now let's follow the formula. It says first A1. So the coefficient of x of the first equation, 2. Now it says below A2, so the coefficient of x of our second equation, 3. Now it says that the second column are c's. The c, we said, it's the constant number. We have them here. Above is from the first equation, -1. And below we have C2 from the second equation, -8. All of that over the determinant of the system, which is -13. Okay, now again, we solve the same way the determinant that we have in the numerator. Main diagonal, 2 times -8, and we will subtract the solution of 3 times -1. which is our secondary diagonal, over minus 13. Okay, now we multiply. 2 times minus 8, minus 16, minus 3 times minus 1 is minus 3. We can skip that step, and we know that it's going to be negative times negative and becomes positive. So we can write positive 3, okay, over minus 13. Now, minus 16 plus 3 equals minus 13 over minus 13. And minus 13 over minus 13 gives us positive 1. That means that y equals 1. Okay, so that is how we solve this system of equations. But now we want to check if we are correct. So in order to do that, we substitute our values in the original equation. So let's go with our first equation. It says 2 times x, which is minus 2, plus 3 times y, which is 1, equals minus 1. Now let's solve and check if that is true. 2 times minus 2 is minus 4, plus 3 times 1 is 3, equals minus 1. Now we add minus 4 plus 3 is minus 1, equals minus 1. Okay, we got the same numbers on both sides. We are correct. Now we check with our second equation, because sometimes it can be correct for one equation but not for the other. And since we are solving a system of equations, the answer should be correct for both equations. So let's check for our second equation. 3 times x, which is minus 2, minus 2 times y, which is 1, equals minus 8. 3 times minus 2 is minus 6, minus 2 times 1, 2, equals minus 8. Okay, so now minus 6 minus 2, minus 8, equals minus 8. So we are correct. On the next video, we will see another example of how to solve systems of equations with two variables by determinants. Thank you for watching this video.